Yeah, well, we can do a quick round. Yeah,
Oh,
okay, we're live.
cool.
Malikeh.
Yeah, I realize now. Okay, cool. So, hi, welcome to the Small Language Model Show. This is Malikeh speaking. I'm applied NLP research scientist at Arcee.ai, and today I'll be co-hosting the show with Julian Simon. So I'm super excited. This is the first time we're co-hosting the show together. And we have two very special guests today, Milica and Jekaterina, and we're going to discuss the interesting topic of efficiency of LLMs. Welcome to the show, Milica and Jekaterina. So
Yeah,
to start with, welcome, Milica. Yeah, can you start with telling us a bit about yourself?
yeah, for sure. I can start. Yeah. So my name is Milica. I am an AI consultant at Google. What I do on everyday basis, I lead teams that build AI solutions, production-ready solutions with various external customers. I also have been teaching ML and AI for a number of years now, since graduate school, so it's been a minute. And I'm involved in like AI educational community, so to speak. Otherwise, I live in Chicago and have a dog.
Very welcome to the show. Yeah, I had the pleasure of meeting Milica at one event by AI Market Space, and I'm super glad that our paths cross and now we're here again. So yeah, thanks for accepting the invitation, and welcome to Katrina. It would be great if you introduce yourself to the audience.
Yeah, sure. So my name is Jekaterina Novikova. I'm an AI researcher, and I study computational models of natural language, large language models as well. Right now, I lead science efforts at the AI Risk and Vulnerability Alliance, ARVA, and my work mainly explores how language-based AI systems can be used in different domains like natural language generation, human-robot interaction, and detecting cognitive impairment and mental health issues. I have my PhD from the University of Bath in the UK, and I have more than 10 years now, I guess, of experience working in both industry and academia. I've been involved in several large-scale open source projects previously. And on the personal side, I live in Toronto, Canada, and I have a cat.
Yeah, nice.
All right, so it's a draw. It's a draw. Good. I love the balance. We need balance.
Yes.
Nice.
So
Well,
today we have a cool topic, right? We're going to focus on how to make large language models, and I guess small language models too, efficient. So because we have very bright people here and because they're scientists, the first thing we need to do is to define the problem. So what do we mean by efficiency? I guess you could write a book or several books on the topic. So why don't we go around and give a short definition of what efficiency means to us for language models. So Milica, why don't you start?
Yeah, so I think we'll be approaching most of these questions from a real world perspective. I think that the most important thing, strictly speaking, is going to be how do we define some constraints, right? So when we're working with the real world problems, when we're applying language models in the real world, we're really focused on what are our constraints. And this can be anything and everything, right? It can be something from very typical kind of machine learning constraints. Is this something that needs to be delivered in real time, close to real time, or not? If we're talking from like enterprise organizational perspective, we need to talk about money, right? So what is the budget
Always.
for this exactly? How are we serving this? Do we have any data constraints? So from efficiency is going to fully depend on defining all of these constraints and then finding a balance between all of them. And then I think probably we can dive deep into each one of these.
Oh, we will.
Right. Right. Yeah. So diving deep into each one of these categories, also we can, each one of these kind of like large buckets, we can then further distill them down into very specific things. Like from a technical perspective, latency is probably going to matter the most, and so on.
Okay. Jekaterina, what do you think?
I like the practical approach that Milica mentioned, but myself, I probably have slightly different, like more research-focused approach. And when I think about efficiency and the efficiency of language models specifically, I mostly think about like the area of research on the efficiency, and that area covers, it's a huge area, I would say, and it covers mainly three different perspectives, which are like model-centric perspective, data-centric perspective, and framework-centric perspective. And again, I also think that we are going to speak more about each of them later today, but like just several examples probably to mention here would be like for model-centric perspective, it's everything about model compression, like quantization, parameter pruning, low rank approximation, stuff like that. For data-centric, it's like data selection, prompt engineering, and from the framework-centric, it's about the system level optimization, hardware, and stuff like that. And the purpose of efficiency obviously is to minimize or at least reduce the need of resources that are required for both deployment and training of these models without losing the capabilities, those like exciting capabilities of language models that we all are aware about.
Yeah, great, thanks. So I think when like things started in the field, like with ChatGPT, Llama, and everything, we were hearing a lot that let's just scale up, larger like parameter size, and then bigger data size, and people were putting more fund in the field to like make the models bigger and train them on like more and more data. But now things are getting changed. So like we're seeing the trend are getting different. And like I really like to ask that, how do you approach to keep this trade-off between model size, data size, efficiency from your perspective, all those definitions you had, and performance? So how do you make this balance between those compared to a year ago, and that people were like, okay, we don't have funding, so we just put everything aside for the big companies and we just wait for all those big models to come in. But right now, how do you approach this? Yeah.
Can I start here?
Go for it.
Please.
I'd say that whether it was several years ago or it's like right now, it's happening right now, I think like in all the cases, it's the start of that trade-off or that decision about the trade-off. It all starts with the budget. I don't know whether it's the lucky thing or the unfortunate thing, but it's all about budget. And
it's real life.
Yeah, it's real life. And the
Yes.
availability of both data, access to data, and the budget for the data as well, and budget for the compute. And in my experience, I have a lot of experience working in the highly sensitive domains like healthcare, machine learning for health. So in my experience, it's also what contributes to this decision of how to reach the trade-off, the most optimal one. One thing that contributes to that is not just the design decision or technical decisions about the compute availability, data availability, but it's also like an important question of interpretability and explainability of the models that should be answered like in the initial phases of each project. And I think when we speak about efficiency, we mostly speak about the availability of computational resources, and the availability of data, and the existing efficiency techniques and the efficiency method. They can help with both of these points a lot. That's my opinion of how to approach these. And in my view, efficiency by itself is that trade-off. It is about that trade-off between accuracy and like the everything else.
Cost and resource availability and everything else. Yeah, that's a good point. Milica, what's
Yeah.
your take on this?
So I think that some of these things are spot on. When it comes to budget, I do want to say there are a couple different aspects of it, right? So one part would be budget of how much we want to spend to actually build a solution that we're building. And then another aspect is of this money is like how profitable this is, right? So it needs to be also trade-off there. Like, are we building something that we're going to spend X million dollars on it or whatever $1 million on it? But is this actually going to bring value to the organization or to whatever? And what we're building actually is, at the end of the day, it's going to come down to how profitable the solution is. So
Right.
on one hand, it's that, but to go back to some of these technical things, right? So we have the original thing was model size, accuracy, efficiency, and trading all of this off. So on the technical side of things, the best thing is what is the most important. So sitting down and stating, okay, what is some of the must-have important criteria you want to say that your solution needs to have, and what are some of the things that are absolutely non-negotiable. So going from there and defining what that solution needs to look like, and then kind of back engineering the problem, or what are some of the trade-offs that we're willing to take. A lot of times, as Jekaterina said, in regulated industries like healthcare, life sciences, finance, we don't really have that. We don't really have the ability to have inaccurate solutions, and that can be tricky, especially if we're talking about like large context window solutions or large outputs. If we're generating something that is massive and we need to be very careful when it comes to hallucinations, right? And like what we're producing is grounded or not grounded. That can be really tricky, right? At the end of the day, your end user, whoever is getting that, also needs to have a way to check that and to be able to account for whether or not what you're producing essentially is grounded, right? So that is definitely like one thing. What kind of solution you're producing? Is this massive? Is this not massive? What is the capability of the end user to actually be able to ground to like check for this? And then technical aspects. How are we talking about a real close to real time solution? In that case, latency is big, and I think that these smaller models are playing a big role there. So one thing, because again, it's going to come down to money. Do you want to put more resources into your compute, into just pumping those GPUs or whatever you're using, or are you going to try to actually make it easier on a model side and not use this massive model that is going to take, I don't know, like 45 minutes to produce some output? Maybe you can you can make it faster by using a smaller model. So at the end of the day, I think that the best approach is to sit down and be very clear on what the output needs to look like. And that can be tricky, right? Because, and we can touch upon that a little bit later, but that can be tricky. Like, what is that ideal output looks like, and what are some of the must-haves that the solution needs to follow that are non-negotiable?
Yeah, totally. And that's the discussion I have with customers all the time. They want to talk about models and GPUs and whatnot. And I try to take them back to my most important question, which is, okay, what are you trying to do here? What's the business problem you're trying to solve? What's the KPI that's going to show success? And if you're trying to predict, if you're trying to recommend, products on a very large volume, large scale retail website, that's one thing. and latency and throughput are a big problem there. But on the other hand, if you're trying to predict or detect, tumors in medical images, latency is probably not that big of a problem, but accuracy is, right? So people wouldn't compromise on even a tiny digit there. So yeah, what is the problem you want to solve? What's the KPI? And then from there, what you both explained is absolutely right. Just try to frame that project and the key things that it needs to deliver, and from there, and yeah, the budget will be a factor. And then you try to find the best, the sweet spot, honestly. Yeah. So let's move on. Let's take it down maybe one level. So you both hinted at some cool techniques to improve the efficiency of training. So we'll get back to data efficiency. Jekaterina, you mentioned that. I think that's a super interesting topic. So let's keep this one for now. Let's save it for now, and let's maybe double click on training techniques. So what do you see out there in your projects? What is really making a difference? What could you recommend to our audience? Maybe start with Jekaterina.
Yeah, absolutely. When it comes to training, I see quite a bit of very cool novel techniques that are popping up like almost every week, probably.
Hour.
And yeah, or maybe even hour. Yeah, exactly. And some of them are better known. Probably because they have some open source libraries or some open code, or maybe because they're slightly, for a longer time out there. Some are less known, less well known, but I would mention several ones that are worth attention, in my opinion, for sure. So quantization, low rank approximation, all these things, mixed precision, all these things, all these techniques are important to optimize the training stage, the fine-tuning stage as well. Model merging, obviously, one of the things that let employ the benefits and the value of several different models and combine them into the resulting model without increasing the size of the resulting model. Something which is some technique that is more recent, probably, and probably not as well known to the broader public, is the so-called parameter sharing. And
Can you explain it?
yeah, I can. I will explain it on the high level, but
All right. Yeah, sure.
if people are interested in the details, I would recommend to read the paper on the Moby Llama. Moby Llama, one word. That's the name of the model that uses that parameter sharing for training. And this technique on the high level is quite like easy and obvious, maybe, but the fact that the result is working and the performance is improving using that technique with the less resources is fascinating. And actually, the point of this technique is to reduce the number of parameters of the model. So in the paper, for example, they reduce the model of like 13 billion parameters to almost twice of the size by applying like a very careful parameter sharing scheme. And they reduce both the size of the hidden dimension layers and also the number of those layers. But the trick here, obviously, is like what exactly to reduce, what exactly to remove from the architecture in order for the final result to be, performing on the acceptable level. But the outcome here, the result that they present in the paper is that with twice less parameters, the model is achieving as good performance as the
Yeah,
twice
that's a good
bigger
one.
one.
That's a really good one. Thank you for mentioning it. Yeah, I mean, I'm all for model merging, of course, for obvious reasons. I'm the local hero, and I love quantization, but yeah, there's more.
Yeah, nice.
Milica, what do you think? Come on, keep double clicking. You can go as technical as you want.
Yeah, well, that's great, but I'm actually gonna I'm gonna say here, this is not something that I do on a daily basis at all.
Okay.
So yeah, I it is very rare that we see the need in my field that we actually train a model from scratch. That's almost
Uh-huh.
never going to happen. So we either approach fine tuning, or something. Fine tuning would be probably the most technical that we would go when working with customers thinking about it. I'd say that when it comes to like LLM efficiency, I'm going to throw another aspect of that. Yes, there is like a model itself and what you can do to train a model more efficiently. But when we're talking about, again, implementing all of this in like a real world scenario, something that not a lot of, at least not a lot of people that I've heard talk about, maybe there are just like a few here and there, is the, well, that's a whole other topic, but is the aspect of how do you put this into like a larger system? So how does this fit into a larger system, and how do you solve it for that? And then how do you make that more efficient? But yeah, in terms of like a training model itself, that's not really something that we do on a daily basis in the industry. You would usually reuse models that have already been trained, and that would be fully like a preference on whatever kind of model you want to work with.
Mm-hmm.
Yeah, so that would be my response here.
All right.
Yeah, I think there are many decisions to be made, like which model should we take, and then how we train it, and like at every layer of training, what approach we use. Like as you said, like there are many of those parameter sharing, model merging, distillation, freezing, pruning. So, and what mix actually works from scenario to scenario. We sometimes we see it fails, sometimes it works. So there are many important decisions to be made, and like in practice, those are very different. Now we have two open source. One is DistillKit that we use for distillation, and I think it's really brings the opportunity of bringing a smaller student model and just compress all the information within it. And I really found it interesting and helpful as one of the techniques that we can use in the field. So very insightful feedback. Thank you. Yeah, Julian, do you want to bring up any follow-up questions?
Yeah. So let's talk about data efficiency, because
Yeah.
I think this is again, we're all so obsessed about we're all engineers and scientists, and then we're all obsessed with all the latest toys. But at the end of the day, the data is what makes those models great. So if my intuition tells me, yes, there's a lot we can do on data efficiency, making that data denser, more and more knowledge packed, more interesting. And maybe at the end of the day we need less, right? And if we have less data, then we'll just train faster. So Jekaterina, please tell us a little bit about that, and then we'll hear about Milica as well.
Yeah, thanks for this question, first of all, and thanks for the focus on data. I personally am a huge fan of the data-centric approach to efficiency, and one of the reasons is exactly what Milica mentioned, when answering the previous question. It's not usually like all these model-centric techniques. They are very interesting technically and scientifically, but it's not what we do in the industry, or it's not even always what is the focus of the academic research as well, due to different reasons. But data is something that is important to everyone, and I think that data-centric approaches should be the very first step to both efficiency and the improvement of the quality of models and many other things as well. And when it comes to data, I believe that, and there are many evidences of that as well in the research, in the applications, that careful curation and caring about the quality of the data can change the performance of the models significantly. So when we think about, let's say, scaling rules that were presented in the Kaplan's paper like some time ago in 2020, I guess, and then reformulated in the Chinchilla paper. Those scaling rules, they show the relation between the amount of data and the amount of the size of the parameters in the model, the size of the model actually. And the Chinchilla paper was probably one of the first evidences of how the smaller model, the model that is 4 times smaller in terms of the number of parameters, can outperform that for size bigger model.
And we see that if you look at the Llama 3 models, you see that, right? The number of tokens that they're trained on is insane, and it's trillions. And now the others do the same, but I think Llama 3 is the ultimate proof of the Chinchilla scaling law. Just more tokens, and not necessarily, and better tokens too, and not necessarily bigger models.
Also, the Phi models of Microsoft.
Oh yes, the Phi models are amazing. Yes, absolutely. Milica, what do you think of this?
Yes, I think we can approach this from 2 different perspectives. We can talk about kind of like a data governance side of everything and how organizations approach that. And then we can talk about actual like pre-processing side of data and preparing the data for training or for whatever work you need to do. Or on the data governance side, even though it's not intuitive to think that that's very important, it's like, oh, like whatever. When we think about what's the goal at the end of the day of everything, and it goes back to, before we rebranded machine learning into AI, what is the goal of everything? It really is generalization, right? So even for large language models, when you're building a solution, you really want to be able to generalize on some future, whatever use cases, right? What future samples, future instances. So it does go back to that like original idea behind like why we've been using machine learning is to generalize and to automate a process. So the data governance, their data governance piece is very important, because in an organization, whatever it is, where you can talk about enterprise, we can talk about startups, we can talk about academic organization, whatever it is, if the organization doesn't have data governance set up, and if every time that you're using the solution that you're building, you need to essentially overfit it to your new sample, it's kind of like a failed solution, right? So you need to create a solution that is going to be able to generalize and not overfit. And that goes back to data governance. How are you organizing your data? Are you have frameworks set up in a way that, whatever new data is coming in, it is going to follow the same kind of like a general structure. Again, if we're talking about like a large context window, then we have to be able to generalize the solution, right? We need to have whatever we're using as maybe our source documents or whatever it is, it needs to be generalizable every single time to like all the future use cases. We can't just expect to overfit every single time or to customize every single time. It's not scalable. It's simply not a scalable solution. So that is one aspect, having the data governance around it, and really spending some time to think about how you're actually doing it, and are you investing in that scalability in the future. And then the other aspect is the pre-processing of the data, which also matters a lot. And again, it can matter not only because of the solution that you're building, but that generalizable aspect. Are you actually what's the data structure that you need to follow in order to be able to create the solution that, in the future actually is going somewhere. So when we're thinking and talking about the data in terms of efficiency, I think that the work that you're doing beforehand is actually way more important than like just feeding and dumping everything and anything. That is, in a long term, absolutely not scalable. So it doesn't matter if rarely I'm going to be working with like a training brand new large language model from scratch. But when we're talking for any solution, whether that is fine tuning, RAG, simply feeding in context, whatever it is, whatever kind of solution we're talking about, unless there is that data and unless pre-processing can be done in some structured way that is repeatable, it is hardly going to be a scalable solution. That it's all you have to assume that you're always going to have to overfit, essentially.
Yeah, great points here. So I think while day by day we see news from models that a new model is coming out, like from my perspective, the value of how much important that data side is sometimes undervalued. And I think we see a lot of papers coming out these days, like instruction pre-training, like data mixing, like Doremi paper, all these. So everything is just the same. Just the way you add the fuel to the model is different. So whether I mix generic data with dominant specific, how the structure should be like. And like initially we were just doing fine tuning, SFT and everything. And now we see people with very good structured mix of raw text with instruction data. Even CPT level, they are getting a lot of good results. So it's all about the matter of the data decisions, not anything about the model. And it's really hard to catch up. And other than that, the problem of fresh data, that until when we will have that day by day, we have shift in distribution. But other than that, a lot of these data are behind the scene proprietary. So I think that's very good.
And if I want to add one thing, actually, you just made a really good point when you said like industry specific. Actually, another thing to keep in mind is that a lot of times this data is not going to contain just text, right? And that's also something we need to think about. So like, how do we handle non-textual data? And can a model handle non-textual data? And are we training the model? And are we using these models to be able to handle non-textual data, and how efficient that is? Or do we still need to deploy some other solutions where, we're first extracting this data, pre-processing it, making it into text, and then doing it, and how efficient that is? And it's really going to depend on like what type of data we're talking about. So there's a lot of, I'd say, edge cases there to also think about, maybe we cannot just assume that everything is going to be plain text, unless it's very specific, just plain text. But in most of the cases nowadays, we're not talking about just plain text. We're talking a lot of very tricky things like tables, and how and all this data the tables can contain, and how are we handling that, and how are we dealing with that. And then what you said, kind of like industry specific things, is a big thing when we're talking about these big models that are generalizers, and not like a smaller specific models. It's, can this model really handle every single solution, and how much of that kind of like in-memory model already contains? Or do we need to deploy some of these smart solutions to make it work on everything and anything?
I have a quick follow-up question. Oh, yeah. Okay, quick follow-up question, and because I'm obsessed with the data. Can and maybe Jekaterina, you can start answering, and then Milica will answer. Can you talk about data deduplication, why it's so important and why it's so difficult?
My view on data deduplication is actually, I do not have a very strong opinion, to be honest, on data deduplication, because like in theory, it is it seems to be very important because it kind of increases, that's the technique that increases the quality of the data by removing the data that copies itself, like removing the copies of the same data or same type of data. But on the, so it looks like that's what we definitely need to do as a data pre-processing step. But some of the evidence shows that it does not necessarily actually work. And the duplication is
Well,
not
for each paper that
always
says, black, there's a paper that says white. So I guess I read the
absolutely.
one that says it was important.
Yeah, so most probably that's the
Okay. All right.
usual
Fair enough. Fair enough.
case
I stand
where
corrected.
everything works within a certain context and does
Exactly.
not necessarily work everywhere. Yeah, so data deduplication is sometimes important, sometimes
Okay.
maybe not that much.
All right, Milica, can you come to my rescue? Oh, sorry, you had you had a
Yeah,
point.
I just wanted to give two additional points
Yes,
about the
please, yes, please.
data
We have time. Don't worry.
that I just realized I missed, and then I will let Milica answer about the duplication. So those 2 points that are important, I think, is one thing: synthetic data. We haven't
Oh,
spoken
yes.
about that yet, but it's an important area because like some research shows that we are just going out of data, out of internet. We may go out of internet very soon, and most of pre-trained LLMs, they are pre-trained on internet data. And the second related point is that internet data, is it fair? Do we have enough of fairness within the data that is represented on internet the most, which is English data comparing to other languages, and some kind of other biases that
Oh, yeah.
we may
Hyper
not
information.
even be aware of because of the open source questions and all that
Yeah.
debate.
Yeah. Okay, Milica. Okay, what do you think about? So, is data deduplication a waste of time? Have I read the wrong paper?
Yeah, I think it doesn't have to be. I think it's more important when we're saying data duplication. I think it's sometimes tricky to also duplicated data, and I think it also kind of like fits a little bit what Jekaterina was saying here with the last response. What is duplicated data, and is it truly a duplicate? I think it's going to come to that as well. So sometimes, depending on the context of the data and on the context of like what's happening, that actually might not be a duplicate, and it actually might be that it is a completely something different. It just contextually it might seem similar, but it contextually is different. So I think that's a very tricky part when we're talking about automating a process, when we're doing something like a data duplication in an automated way. These are some of the things where even like the from kind of like a NLP technique perspective, can we really tell this difference in a contextual way? Can we actually really make a difference in context? So that's probably a problem to solve there.
Okay, that's good advice. All right,
Nice. We have
we have we have a few minutes left. Malikeh, should we do questions?
uh, yeah, we
Audience
have
questions?
some very interesting questions in the chat from the
Yeah.
audience. Thanks for the
Okay, fire away.
Yeah, so for the first one, we have, I think Michelle asking, what are your thoughts on phi models, particularly regarding the challenges associated with fine-tuning them and improving their performance?
If I'm to answer that question, I'm probably not the greatest one. I don't work with phi models very, very much, if at all. So, and probably not the best person to answer that. But overall, I think it is going to, at the end of the day, depend. I think nowadays, to go back to some of the comments, how similar or how different some of these models are, it's going to, at the end of the day, come up to what is the infrastructure that you're using, how easy is to implement that infrastructure, how scalable your solution needs to be, who you're serving the solution to, rather than necessarily picking a model because one is better over the other. I think some of these other organizational prep, if we're talking about large organizations like enterprise, if we're talking about organizations and companies, yes. If we're talking about, kind of like an individual, yes, you can test everything and anything. But in a scalable way, I think it's more going to depend on, you're not going to choose necessarily a model based on just performance of that model, but rather you're going to try to fit it into this larger ecosystem of, what are you using to begin with?
And you have to standardize, it's, of course, you have a million models on Hugging Face, but even if you look at the base architectures, no company is going to work with 300 base architectures. They're going to standardize their data set efforts and their MLOps efforts and their skills, right? So maybe they'll go with, okay, they'll standardize on Llama, or they'll standardize on Gemma, or okay, maybe 2 or 3 architect on Mistral, maybe 2 or 3 of those, and then over time that list evolves as it should.
Something to think about is,
you can't just try any and deploy in an enterprise setting any model that thought like last night. It's unrealistic.
And another thing to think about is how current these models are, and are they actually being refreshed regularly? And if they are being refreshed, is the support being offered for that? Because you can build a solution for a model, and the model gets refreshed and the solution breaks. That actually does happen.
It does happen. Yeah.
It does happen. So it is something to think about, and it's not maybe the most intuitive thing. It's like, I'm going to use the coolest and the latest. Well, sure, but the coolest and the latest might be like a one-off thing, and it's not something that is actually being maintained. Absolutely. And then you're not getting support. And if you're not getting support when things break down, that can definitely be an issue.
All right, I think we have time for a couple more questions. Malikeh, keep going.
Sure. Hi. Yeah, we have Nikhil here. Hi, Nikhil. We did masters at the same university. So, what are the faults of panel decrease of performance when using PEFT or parameter sharing techniques?
Interesting.
Can you repeat the question? What is the decreased performance when?
What are the faults of panel and decrease of performance when using PEFT or parameter sharing techniques?
Jekaterina, do you want to take it? Or do you want me to take it?
Yeah, you were advocating for parameter sharing, so come on.
Yes, so I should answer this one. I think this question. I think what is important when you're using all those techniques like PEFT or parameter sharing, what is important is to think about the application, the final application. So as in many other cases here as well, the acceptable level of performance is what is important. And the acceptable level, depending on the application purpose, is not necessarily 99% or like close to 100%, or not even necessarily the human level of performance. It can be there can be some acceptability range, or like the actual range that is outperformed by a big margin with the model that was not that was fine-tuned without using all those optimization techniques. And then the question is, do you want to spend weeks of compute and the majority of your budget in order to achieve the level that is very high, but you not necessarily need it? I think that's the question of trade-off.
I would also add a couple of things here. I think when it comes to these fine-tuning techniques, it's going to come down to data again. The data is definitely going to be the most important part here. Do you have enough data? Do you have high-quality data, and so on? But also, we haven't even gotten there. We haven't even mentioned this today. But when we talk about evaluation, there are two types, right? We're talking about technical metrics, and technically, like whatever we choose, the metric, like some metric that we're choosing, technical metrics. But there are the the user evaluation metrics, which is like how actually subjectively good solution is. And those are two different things. And I'd say that those three components are going to, and it doesn't have to be decrease in performance if you're using some of these fine-tuning techniques. It actually could increase the performance depending on the task that you're solving.
All right, I think we're at time. So should we wrap up, Malikeh?
Yeah, if Milica and Jekaterina, do you have any points? Do you see anything like any last points for the audience about the future, how these gaps should be filled, just to wrap up the call? Yeah, very insightful points from both of you.
The biggest thing, educate yourself. Education, I'd say there is a huge gap in education, especially with between technical and non-technical audience and non-technical users. There is a lot of expectation of perfection, and that large language models are magic, which they're not. And so I'd say education, or not yet, education and closing that educational gap is a big one.
Right.
Nice.
My point would be lower level a little bit. I think that we are going to have to see a lot of advancements in the future within the area of algorithm hardware co-design. And for people who are at least a little bit interested in hardware, I would specifically recommend to look into flash attention. And that's such a cool technique that I'm personally excited about. And like that area path of research, I think is very interesting.
That's another episode or another 10 episodes. So we'll definitely we won't run out of topics. And you can come back and we can chat about flash attention and page attention and TGI versus VLLM versus everything else. And we could stay busy, right? So I think we're at time. I want to thank all of you very, very much. I know everybody's busy, and Milica, thank you so much from Chicago, and Jekaterina from Toronto. Malikeh, as usual. Where are you now? Are you on the West Coast?
Yeah, I'm in Toronto still. Yeah.
Oh, you're still in Toronto. Okay. Yeah, so it's mostly it's mostly an East Coast and Midwest episode, except for me, of course, on the other side of the pond. So thank you very, very much to our guest. Thank you to everybody who joined in. I think we have a few unanswered questions, so we'll try to capture those and follow up. And I think that's it for today. So thank you so much. You'll be able to see this and replay that very insightful episode. And we hope to see you for the next one in a couple of weeks, I think. Right? Thanks again. Keep learning. And we'll see you next time. Thank you so much.
Thank you.
Thank you.
Thank you. Bye.